the best.
So here's our.
Oh my gosh. Hi guys. This is a really neat project. Tell me about it.
So what we're gonna find out is orthophosphate is the best corrosive inhibitor out of out of the four inhibitors, which was orthophosphate and then glycol.
Let's try it again. Polyethylene glycol.
Polyethylene glycol.
Yeah.
And then sodium silicate and methane.
Fantastic. So how will you do this experiment?
Okay, so we have 4 beakers that are filled with H2O, and each one will have like a different corrosive inhibitor, and then there will be a lead-infested nail to see which one will be the best.
Okay. So tell me a little bit more about the hypothesis. You know how we use those sentence frames? So I'd love to hear your hypothesis using a sentence frame.
If we use orthophosphate as a corrosive inhibitor, then the water will have less corrosion because orthophosphate creates a protective layer between or inside the pipes.
That's an interesting hypothesis. Can you tell me a little bit about the chemistry behind it? What do you think the protective layer will do?
It will oxidize the lead-infested nail. Yeah.
It'll keep.
Yes.
Yes, it'll protect the lead from being oxidized. Oh my gosh, I love that you both use corrosive inhibitor and oxidation. Being oxidized. So, questions?
When you guys created your procedure, how were you guys able to, how are you guys able to decide whether or not your experiment will be a fair test for each of these corrosive inhibitors?
When we wrote out the procedure, there was going to be 5 different beakers, but like 4 of them will be filled with like different corrosive inhibitors, while one of them won't have any, and it will just only have the lead-infested nail. Well, all 5 of the beakers will have it, but for the control group, which is just H2O and lead-infested nail, while the others will have like H2O and corrosive inhibitors and the lead-infested nail. So we get to also test out to see which one works the best amongst the 4 of the corrosive inhibitors.
How do you know if your inhibitors are effective?
If we get the results, well, if our results matches with our hypothesis, that's how we're gonna know if orthophosphate is the best corrosive inhibitor.
Did you guys draw a bar graph to represent what your expected data would be?
Yeah.
So let's look at a visual response to Leah's question, which was fantastic. Scarlett, do you want to tell me a little about this graph and why you think orthophosphate? Sorry.
In this graph, this is a chart about the amount of lead that will be found in each beaker with the corrosive inhibitors. And since like control, right, it has no corrosive inhibitors, nothing to protect it from against the lead. It will have the most amount of lead inside it. And since orthophosphate is like the thing that,
well, we said that since like our perspective was that orthophosphate will work the best among all the 4, so we would put less amount of lead in orthophosphate than the other corrosive inhibitors.
Thank you, and thank you for highlighting the control group. I love that you brought it up here because I was going to ask you a question about it as part of your procedure.
Using this experiment, how could the results better people's lives in the future?
Sorry guys.
So it will probably help like
a little, you can see like bubbles on the lid a little bit.
Hey guys.
Hi, Ryan.
I'm really excited to hear what you learned about it in terms of like the lead concentration. Someone catch me up.
I think that mine, which is because the last time we checked it, it was at 20 ppm and it's still at 20 ppm.
Oh, it's still the same. What do you think that means?
That like it's working, but it's just staying on the same kind of rate.
Okay. Anyone else? What do you guys have?
I noticed mine says egg. I noticed how when I tested it, it stayed at 20 milliliters of egg. So I don't think there was any like concentration of what happened with the corrosion.
Okay. So you guys are at 20 parts per million, ppm. You're at 20 parts per million. Okay.
Mine is glyphosate and mine is 25 ppm. Just
Ooh.
like last time.
That's different.
Actually, I believe mine is 25 BPM. Yeah, I think that's a change from last time. I think I already have 20.
Okay. Speak up, I can't hear you, buddy.
I may be mistaken, but last time I'm sure I had 200 BPM, and now it's
Can somebody get the door, please?
Okay, so let's look at your specific data. Can you explain to me what you had last time? Please? Okay. And then over there. Okay. Great. So we have our initial hypothesis. What was your initial thinking? Which corrosive inhibitor would be the best? Orthophosphate. And so what are we finding now?
It's wrong. Our hypothesis is wrong.
Okay, instead of saying we're wrong, what scientists like to say is our hypothesis is not supported by the data.
Yeah.
Okay, so the data, what does your data support?
orthophosphate is not the only corrosive inhibitor that's good for the job.
Okay, is there a better corrosive inhibitor that you found?
It seems like and so there's like the best at all of them.
What makes you say that?
This is the one with the lowest levels.
How do you know that?
Because our data.
Yeah, your data says that it's 20, right? And so we've got two that are sort of tied. Now let me ask sort of a real world question here. If you're a city official and you have to choose between those two corrosive inhibitors, what factor would you consider in choosing the corrosive inhibitor?
How much lead it can decrease, or how much lead it doesn't have.
Great, so its effectiveness. What's another thing you might have to consider? Could it save?
The cost.
The cost. Why do you think the cost might be important?
Because if you're using one that has a high cost, then it might be like less expensive in the long run wise.
Yeah? Yeah. So we've got a checklist here. Where are you on this checklist? Step 3, what does that say?
We're recording our data and using Google Sheets and paper.
Okay, so how do we think we want to represent our data visually?
We want to represent it in a way that is educational, but also visually entertaining.
Okay, so something that's like easy to read, right? And it's like visual. Have you considered the type of graph you want to use? Wait, you are a graph. I think that's a fantastic way to represent it. Do you want to do it on a sheet of paper, or do you think this might be helpful?
I like to do it on the sheet.
You want to do it on a sheet of paper? Okay. You want this also? How do you want to do this? You want to try Google Sheets? Okay. Let me give you the directions for Google Sheets. I want you to try it first, and then we'll come back to you, okay? Okay, you can use that desktop. Okay?